Hello everyone, it's April the 6th. Had a very bad day today. If you guys remember, yesterday I got stuck on some reinforcement learning and I remain stuck until now. I think I've been spent more than 10 hours on this and it just didn't work. Very frustrating. I was trying to do actor-critic network for reinforcement learning, but something just didn't work. It's my understanding might be off, or I cannot do on policy. I have to do off policy. It just seems like that's the way to go. I have to create a replay buffer to do this. Anyway, I want to change my mindset, just switch to something else. So let's take a look at today's challenge. Hopefully this one is a bit easy. I kind of hope it's going to be easy, but we don't know. Let's take a look. Ooh, 2 hints. Minimum operation to make array equal. Okay, you have an array of length n, where array I equals 2i times 1 for all valid values I. Okay, in one operation you can select 2 indices x and y and subtract 1 from array x and add 1 to array y. Okay, the goal is to make all the elements of the array equal. It is guaranteed that all the elements of the array can be made equal using sum operations. Given an integer n, the length of the array return the minimum number of operations needed to make all the elements of array equal. Well, I mean, the array is deterministic, right? Given the n, there's only one way to do it. So array is this. So all the you can select 2 indices. One operation, you can select 2 indices. There's no requirement on the positioning of x and y. You just do 1 subtraction and 1 addition. So choose x equal 2 and y equal 0. So this one will plus, this one will minus. And then do the same again. Okay. And if it's 6, that's 9. Write it out. 6, 1, 3, 5, 7, 9, 11, right? 1, 2, 3, 4, 5, 6. And then we take 9 operations. Well, 9 operations. Of course, the ideal is to get the big number smaller and get a small number bigger. So, big number smaller until what? Well, until we reach the center, right? So the center, okay, I have some, so the center we can do, and then next step will be this, and then here we go, 2 and 10, 3 and 9, 4 and 8. 5 and 7 and 6 and 6. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. If I'm not mistaken, this question is, think about it. If we have like 3, right? We have 1, 3, 5. Obviously, to make them equal, we just take the first one, we raise that to 3, and the last one we decrease that to 3, right? So that's 2 steps. And for it's 6, it's 1, 3, 5, 7, 9, and 11, right? So the middle one, these 2, we can make that to 6, right? So that's 1. And then this to get to 6, we need 3 steps, that's 4. This get to 6, we need to 5, so plus 5 is 9. Which means if we add another one, right? If I add another one here, 13, which we can test here, everybody should be 7, right? So basically this needs 2 plus 4, that's 6 plus 6, that's 12, right? So we should return 12. which if it's 7, see if it's 12. Yeah, I think that's the solution. I think it is easy. Well, again, don't say that. Don't say that. This probably consider what, a greedy solution. I don't know. I am just so stuck on that algorithm. Don't know how. Don't know what I should do to make that work. Reinforcement learning is a big black box. I mean, I have implemented a lot in the past, but this one's it's just not working for whatever reason. I actually have a tutorial. So I mean, worst case scenario, I just go with tutorial. Shall give us good results. But I kind of don't want to. I don't want to go with a tutorial. I want to do it myself. But I guess at the end of the day, you have to decide. All right, let's just see. If it's even number, then we take the middle. If it's odd number, we take. Oh, it's odd number, we take the middle. Even number, we take the average of the middle, right? So what do we say? We say, man, I think there could be a math solution to this. Let's see. Do we know the middle? Give an n, right? We shall know the middle. If n divided by 2 equals, this one will equal 1, right? And the middle is 2 times, and this is divided by 2 is 3, right? So, so like here 7, right? Divided by 2 is 3, so we need to make this 7. So if it's even number, if it's odd number, that is the target. If it's even number, that's the target. 6 is a target. 3 is a target. So that's our target. And we just need to compute how many that need to get here. Well, I mean, every value will be different by 2. So we're only going to consider the front, right? Because they all change at the same time. So we consider front. So it's going to be, for this, is actually plus 1. All right? For this, it's plus 1 plus 3. Because, yeah, it's plus 1 plus 3 plus 5. So if it's this case, then it's odd number. So it's a plus 2. Like plus 2 plus 4 until we reach the end. How many numbers we have? Well, it's n. It's 3 minus 1 divided by 2. That's the total number, right? And instead, in this case, that's 1 plus 3 plus whatever. That's 6 divided by 2. Right, that's 6 divided by 2. That's 3 divided by 2. 3 minus 1. Yeah, so it's 3 divided by 2, which is 1. Oh, that's sufficient. 3 divided by 2. And it's 6 divided by 2. Okay, so n divided by 2. So n divided by 2. And the sum, it depends on if it's even. If it's even, it's going to be... wait, what's the last value? So have the number is n divided by 2. That's the number we're going to do. So we're going to say 2 plus number divided by 2 times 2, right? It's 1 minus 1 times 2. This 1 times n divided by 2 divided by 2. So that's this situation. And then we can do the same with the other situation. Then let's say how do we say half equals n divided by 2? and we say if n is an even number, an odd number, then the answer should be, if n is odd, we're looking at here, so we're adding, so it'd be 2 plus, first plus half minus 1 times 2, right? And then this times half divided by 2. Let's return this. And then I also return the same concept, but I think it's going to be 1. And that's it. Let's see if it's correct. I did a bit fast and then kind of, so 3 should be 2. 6 should be 9. We know 7 is 12. How about 1? 1 should be 0, right? Yeah, you don't need any action. 2 shall be 1 action. Okay, that's min operations. That's not correct. Okay. All right, 3, answer is 2, result is 1. Okay, so it's 3, it's this situation, right? So half is 1. Okay. So it's 2. Half is 0. So 2 times half is 1 divided by 2. How so? It's two steps. It should be 2, right? 2, right, times how many? 1. I think the math is a little bit wrong. The last item, it's 2. Oh, yeah, it's the first item. This is the last item. And the first item, this is the last item. Try this one. Yeah, this one pass. Okay, we can probably write, how do we write this? I'll make it, I mean, these two can be combined. They're basically the same. We can just say start equals 2 if n else 1, and now we can just return this, and then instead of 2, we can say start. Okay, try it again. I'm putting here. Am I wrong? But I'm not sure. So let's try 10 to the 4th. All right, 10 to the 4th. Just give it a shot. Oh, okay. So I think this probably is correct. Yeah, it is correct. So it's a trick question. All right, it's a trick question. It's you can use a math solution to do this. Do we need proof that this is the working solution? I'm not sure. Do we need to prove it? Well, it's asking for the minimum, right? Minimum operations. I mean, you increase and you decrease. I mean, if you find, yeah, the best solution, the best will always be every time you increase and decreasing, both is getting towards the same value, right? So for the big value, you should always decrease. For the small value, you should always increase in order for them to meet. So the best solution is to find the middle value. I guess that's reasonable, right? I guess that's reasonable. this is a math solution. The intuition is to always increment on the smallest and biggest value, incremental and decrement on the biggest value at the same time. This way they will meet in the middle, in the value, in the medium, in the middle value. We do the same with the second smallest and second biggest, and so on and so forth. If n is odd, then the target value to reach is n itself. If n, it doesn't matter. The target value turns out to be n, and if n is even, n is odd, then the number of steps is the sum of 2 plus 4 plus 2 plus sum of this, which has n divided by 2 number, which has length divided by 2, right? If n is even, then the number of steps is the sum of 1 plus 3 plus, which has length n divided by 2 as well. Therefore, we can write a math solution to solve this problem. I guess it's all 1 because everything is just division and stuff. I guess it's also possible to, and these two lines can be combined, and it doesn't matter. It's going to be very fast. Yeah, 32 milliseconds, and this one runs at 80% ranking. I think this is probably the actual solution. Not quite sure. I mean, somebody might come up with a better proof, I guess. I don't know. This gotta be easy, right? I mean, it's a medium, but has a high acceptance rate, which means it's not too complicated. People will figure out eventually. So we are at LeetCode 1551 for this one. All right, I'll take a look. Constant time with detailed explanation. Oh. Well, you can further simplify. Well, I didn't really try to simplify. I think, yeah, you should. You should try. I mean, half is, you can put n inside. You can put n inside. Maybe you can eliminate some of the items. I mean, we're using this, so so the half is, I mean, if n is odd, it's actually if n is even. If n is let's do n is even, right? N is even. We can directly do n divided by 2 If it's even, it has to be 1. So it's 1 plus this minus 1 times 2, right? And then times n divided by 2 divided by 2, right? So we can expand it. Just n minus 1 times n divided by 4. How is this I don't know. doesn't look oh, I forgot this 1 plus. Oh, I forgot a 1. So that's 2. That's, oh yeah, that's n squared divided by 4. Yep. It's n squared divided by 4 if n is even. If n is odd, I guess we can come up with a solution as well. Middle, and then we take, yep. Math one-liner. Oh, I can do that. Huh. I guess it's fine. Yep. This is pretty. I'm gonna upload on this one. I mean, I don't know. I haven't done. Oh, okay, let's be more rigorous on this. I mean, I have proved that if n is not proved, we just put an n in, right? So if n is odd, then we have to do n minus 1 divided by 2 minus 1 times 2, right? And then whole thing times n minus 1 divided by 2 divided by 2, so divided by 4, right? So if we expand this thing, what do we get? We get is n minus 1 minus 2 plus 2, so be plus 2. So it becomes n plus 1 times n minus 1 divided by 4. That's what I get, n plus 1 times n minus 1 divided by 4. Is that the same as this? I'm not sure. Honestly, I'm not sure. So, n times n, do this. I honestly don't know. So what we're saying is n squared minus 1 divided by 4. Oh yeah, it is correct. It is correct, because it's, what my result is n squared minus 1 divided by 4. And n is a odd value. So, because minus 1 divided by 4 is 0, so n squared. But this doesn't look the same as this one when n is, oh, they do this. Yeah, then it changed stuff. It changed stuff. So yeah, so it's either n squared divided by 4 or n squared minus 1 divided by 4, which both satisfy. Okay, yeah, that's fine. So I think I want to try, just to prove solution 2. If we expand the formula, solution 1, and consider while considering n to be even or odd, we shall get result equals n squared divided by 4 if n is even, and n squared minus 1, right, divided by 4 if n is odd. Yeah, and it's odd. Further reference, which I want to reference that result as well. Further reference is, yeah, that I think this is the simplest of them all. Right, this is the simplest of them all. Further reference, let me get this one. So basically return n squared divided by 4. Right? If we try solution 2, shall pass as well. And then we'll do it here, just to see if it's any faster. Don't know. Oh, it is. Ooh, it is faster. Oh, what are you doing? I'm trying to check. Yeah, it is faster, but it's fine. Basically the same. All right, that's it. That's it for today. We did encounter a relatively easy one, so it's good. It's good. Good for me, so I can go back to the reinforcement learning. All right, I'll see you guys tomorrow. Adios.